No, I don't.
Sure, this is it. That's very strange. It says HDMI here.
Yeah, it is. I mean, I had it from my last laptop, and that had the same port. Oh, there we go.
You have to jiggle it the right way.
The
Okay.
the slides are on the side. Oh, fuck it. Does anybody have in the room have a DVI to VGA?
Well, I
You mean DVR or DisplayPort?
No, we mean DVI.
Technology?
Yes. Does anybody have adapters for antiquated technology? That's one.
I don't have a display port. All I have is an HDMI port.
Just start duct-taping all these dongles together. See if you can make it work.
Yeah. Bring me your dongles. Seriously, does anybody have an HDMI to VGA in the room? Anybody? Dig in your laptop bags.
As many displays as DVA.
Let me go find the secretary.
Yeah. No, I don't have a mini display port. All I have is. See, the problem is that I have one of these stupid Chromebooks that doesn't. Because I left my Surface up in the room because I don't. Be stolen. You want to know the truth. I'm roughing it. I brought my Surface and my Chromebook. So while I currently have all the ARC++ goodness, I don't have any way of frickin' displaying. Okay.
Power. Connect the USB as well.
HDMI.
In here, okay.
You plug both.
Plug this in here,
Yeah.
the right way around.
Let's try with this.
Oh, screen overscan. That sounds fun.
All right.
Is it mirroring?
Yeah.
Okay.
Looks good. Yeah.
So when you're done with this,
Return it. Yeah, absolutely. Thank you.
Okay.
So now it's meetings, materials, manager, download, all, everything's uploaded. So,
Where do I go?
go data tracker, meetings, 97 materials.
Just sign in.
No, just go /meetings. 97/97.
Meeting /97.
Yeah, meetings / materials. Yeah.
Oh, meeting.
Oh,
Said meetings.
Yeah, meeting. There we are. Yeah. All right, and then scroll down to Tokbind. Control F or something. This Tokbind. There we go. So we can go open the main deck. Back. Open the main deck. Yeah, those are the settings. So I don't think your display is mirroring. So you have to, no, it's probably sort of to your side or something.
Setting for that.
Maybe you just drag your browser sideways or something.
Can't see the screen.
Maybe if you did presentation mode or something. Yeah,
Presentation mode of
yeah,
The
no,
browser?
just no full screen. The or maybe you can't even do that.
should be a mirroring setting or something.
No,
No. Okay, one of the Chrome OS people needs to come up and tell me how I can get the display on the other. Somewhere in settings?
Yeah.
I'm just trying to display it on the external.
hey, something popped up there.
Yeah.
Yeah. Right.
Yeah, exactly.
And that's what I've been trying to do, but then it's not going.
There we go. There we go.
Okay, yeah, but then I won't be able to see it.
So can you get the settings open up on the screen so you can do your
It's showing settings on the other screen.
Okay, go over there and tell me where to navigate my mouse. Oh, wait a minute. I'm gonna Can I unplug? Oh, wait a minute. Okay. Is it? No. Setting. No, I got. Okay, so set home button, device.
display settings.
There we go.
Mirrored.
Ah, yes.
Darn it. Yes.
Okay.
All right. Now full screen.
Okay.
All right. Sorry for the delay, folks.
This is living on the bleeding edge of this well-established platform.
Go like full screen or something like that.
How did? Okay. Wait, oh, this one.
Yeah. There we go. Can you guys see it now? You can see it. All right. And you see the note well. Can you note the note well as well? To rephrase Barry's immortal terms, note the note well. Anyway. All right. The agenda is seems light, but really it isn't. You scroll to the next. So I guess we were sort of hoping to be done by now, but people insisted on keep talking about issues on the list. So we didn't feel it was appropriate to do a last call for the document because there were clearly open issues. So we decided to devote the entire working group meeting today to an attempt to close the open issues. Now, I think either Dirk or some people from Google or Microsoft have slides talking about right, Andre has, talking about changes and open issues. And we'll try to use that as a driving point to get, so starting point to get closure on some of this stuff. And there have been a couple of people, Brian Campbell and Nick, have come forward asked for time to present and talk about additional stuff if there is time. And we'll get to you guys if there is time. So do we want to switch over to go back to Materials Manager and yeah, open.
Token binding.
Yeah, change it there. And Andre, I don't know. It's your laptop. All right. Oh, by the way, before we start, I almost forgot. Note taker. Can I have a volunteer? Actually, I'm going to insist that Andre stand there awkwardly until somebody volunteers.
Oh.
He's just going to stand there awkwardly.
We'll make him sing.
There you go. That was quick. It was at the point of forcing him to sing that that did it, right?
I had more intimidating things I was going to get him to do. But.
All right. Thank you.
Okay, I'm Andrei Popov, and I will briefly talk about the changes in the core token binding documents that we've made since the previous IETF meeting. Next slide, please. Okay. So it's a little bit cut off, but anyway, so in the token binding negotiation document, we've made two changes. One of them was about, we basically added information about the temporary IANA code point assignment that we've had for a while. Now it's there in the documents. It's the number 24. And we're in the IANA section of the document, we're saying that we would like to keep this number going forward. Then we've added text saying that the renegotiation indication TLS extension is only required if you're actually configured to do it. So if there's a possibility your client or server is going to do it, then you need this extension. If you don't even support renegotiation, then you don't need the extension. That was the comment, I think, from.
Yes. So Martin Thompson, I'm going to renege on that comment after Karthik Bhagavan pointed out that there is an attack if you don't actually implement the renegotiation extension in certain cases.
Even if you don't renegotiate.
Even if you don't intend to renegotiate. So I think it's probably a good idea because otherwise the client doesn't know this. And there's the, it was on the TLS working group mailing list. I can find the email, but
okay, I would like to see that.
You
so
need to have that.
Is that a prefix attack? Probably it's really, yeah. Anyway.
I can't remember the details, but suffice it to say that we should just require it and too bad.
If you can send that message, it will help.
It will be good to understand the message and we'll do that.
Yep. Sounds good.
Nick Harper, I'd like to point out that implementing the renegotiation indication extension without actually supporting renegotiation is really easy to do. So
yeah, it's really easy to do. Yeah. So the next slide, please. In the token binding protocol internet draft, we've made several changes, and some of them affect the format of the messages on the wire. So we've added the length field in the token binding structure that allows an implementation to skip unknown, to skip token bindings that use unknown parameters. So let's say you have a parameter that is not yet defined, for your implementation. You receive that binding, and you will be able now, thanks to that length field, to skip that one and to go to the next token binding message. I don't know how useful that is, but since we're defining a new thing here, we could as well do it. Well, I could argue many things against that, right? I could say that, it's a misconception. So the comment was that in the case of referred token bindings, if the identity provider and the resource server are configured or support different different sets of token binding parameters, then in principle, a server could receive a binding of a type that the server doesn't support. So in this case, the argument is that it's useful to be able to skip that. Maybe I would consider that a misconfiguration, actually. If the IDP and the RP don't agree on the sets of token binding parameters, but it's arguable. So anyway, so we've added this field. It's really cheap, and it could be potentially useful. Then the second interesting change that we made is we added added more information under the signature. In particular, we've added the token binding key type under the signature and the token binding type as well. We also talked about concatenating into the signed blob the protocol version and a label, but those things are already included in the EKM itself. So we just decided to keep it that way. So that's another change we made. Unfortunately, the slide is cut off, so we can't really see this very well. But next slide, please. Okay. More changes in the token binding protocol document. We've added the recommendation that the token binding protocol implementations should make token binding IDs available to the application as opaque byte sequences. And the reason for that is that in the future, if we want to change the format of the token binding ID, we don't want all the applications, to change because they were making assumptions about how it's structured. The next change we made is we specified the parameters of the paddings for PKCS and ECDSA with SHA-256 and PSS padding. So basically, depending on the padding scheme you have to define certain parameters. We're saying we're using SHA-256 hash, and for PSS, we also use MGF1 with SHA-256 and 32 bytes of salt. So these are just parameters of the padding schemes that were previously underspecified. Now, and there are various editorial changes in this draft as well. Next slide, please. In the HTTPS token binding draft, we have several changes. There are clarifications regarding the base 64 encoding. We're saying it's base 64 URL safe, and importantly, we're omitting trailing pad characters. And I think that's something that tripped us when we did our first implementation. So it's important to remember about that. And we explicitly stated that federation can be done within the same ETLD. So your IDP and your RP are within the same domain, basically. And that's in principle, a supported configuration. We just explicitly stated that. Next slide, please.
Just on a quick comment. Base 64 URL is defined in RFC 7515, and you can probably just reference that rather than redefine it.
Yep.
It's just one of the Jose documents, and I think just about everyone now is starting to refer to that when they use this form.
Okay.
No, I didn't see any blue sheets. Okay.
And next slide, please. So we also added implementation considerations for multi-party use cases other than HTTP redirect, basically saying that we define the HTTP redirect scenario in detail, but other scenarios are possible. And we are talking about applications other than web browsers because those applications have specific API requirements that an implementation may want to consider if they want to support those types of applications. There is a new privacy consideration section discussing the potential for correlation based on the token binding IDs. It basically talks about situations where there is no possibility of no new correlation possible thanks to token binding, and how to avoid correlation. And there are various editorial changes as well. Next slide, please. So regarding the implementation status, here's a quick update. So there is a version of Chrome, which is basically beta dev and canary builds of Chrome support token binding. Token binding in Chrome, I believe, is disabled by default, and it needs to be either enabled in the settings or on the command line. IE Edge and the Internet Information Server support token binding draft version 10 as well, but you will only get that with the next review of Windows, I believe. So it's still kind of in the works. We've internally validated the interoperability with Chrome between the IS and Chrome on version 10. So we kind of have two interoperable implementations. There is more testing to do, of course, but basic interop works. On the server side, so token binding in the Internet Explorer and Edge are enabled by default. On the server side, in the IS, there is a registry key you need to set in order to get it, because on the server side there's there's deliberate action on the administrator's part to enable token binding. Next slide. Okay, so there's an open issue that we've been discussing on the mailing list for a while, and it would be good to drive that to consensus today. TLS 1.2 and earlier versions support renegotiation. Basically, within the same TLS connection, you can have multiple TLS sessions. The token binding protocol draft says that the token binding signature is computed over the exported keying material value obtained from the current TLS connection, and other things as well. But basically, the thing is, in the same TLS connection, you could potentially have multiple EKMs over time. So the question is, which of those EKMs do we want to use? Do we want to use the most recent EKM, or do we want to use the EKM from the original TLS session established within this connection? Next slide, please. So if we sign the current or the latest EKM for this session, then the client will be able to prove possession of the token binding key in each TLS session and in each TLS connection. So that's the most proof of possession that we can possibly get for TLS. A bound token then cannot be replayed on a new TLS session, even if this new session has been established on an existing TLS connection. And there is, again, the caveat is that in TLS we've had multiple situations where we've had multiple security bugs where the server could be convinced that the server is talking still to the same client on a renegotiated session, when in reality one session was established by the attacker and a different session was established by the actual legitimate client. We believe right now there is no such vulnerabilities in TLS with renegotiation, information extension, and EKM, but in the past this happened twice, at least. So anyway, and then the third consideration is that the server application, if we do this, if we use the latest EKM, then the server application can be engineered to be completely stateless and kind of request oriented, so it doesn't have to track connections. Basically processes each request as it comes in and responds to it according to the information that it has. So the other thing is the client and server. In this case, if we go with this design, then the client and server need to ensure that the correct EKM is used when processing the token binding message. We can say that the TLS stack always knows which EKM corresponds to any application data record that is received, because the TLS stack needs to first of all decrypt that record, and for that they know which master secret is used, and based on the master secret they always know which EKM corresponds to this application data record. But it is not true that the application necessarily has this information. It's a question of the layering in the system. How is the system designed? Is the same machine processing the TLS handshake and the token binding information? So all of those questions. So potentially this design makes the implementation more complex, because the EKM information has to flow together with the application data.
Yeah. So Martin Thompson, I think you've got the most sensible design here. There are always cases where you have problems. For instance, the client pulls the EKM from the TLS connection an instant before a renegotiation completes and new keys are installed, and then it writes the request out with that EKM. But that would require that someone initiated a renegotiation at a time that's actually quite odd. The most common use case for renegotiation is to grab a client cert.
Right.
Using client certs and token binding seems like it might be a little bit in the sort of marginal use case category. But in those cases, it's often the case that the client generates a request, sends it to the server processes that request, decides that it needs to renegotiate at that point before it completes the request. And if the server does that, as long as it extracts the EKM or checks the token binding before it initiates or even completes the renegotiation, then it's fine.
Right, right. So there's always a way to do it, but for some implementation, for some implementations, for example, if they want to verify token binding on a different machine than their TLS terminator, then
there's lots of added complications.
Yes.
I think the key point that we need to address here is that we mentioned that renegotiation is possible.
Mm.
We mentioned that implementation should use the EKM that comes from the session that is currently active. Now that may be interesting in cases where you have a renegotiation that ends during the generation of a response, or a request rather. And simply note that there may be some of these nasty corner cases, and this is where maybe we should rediscuss the issue about whether a token binding failure should cause the connection to be torn down.
Well,
it depends on how much you care about all of those corner cases, right? If you don't care about the corner cases or think that they're highly unlikely, then it has no bearing on that discussion at all. And if you do care about those, then
I just believe that if we are to pick this option, then the implementation that does this, that supports renegotiation and supports token binding with renegotiation should do it properly. So the corner case doesn't.
What is properly?
Happen.
What happens when you have a request that comes in where the renegotiation happens right in the middle of the token that arrives, right? You can actually have a renegotiation that happens between the second and third bytes of the token binding value. It's possible, unlikely, but it's possible.
Well,
what are you going to do?
So any application data record comes either before or after the change cipher spec.
Right, but the application data record could contain the first few bytes. One can contain some bytes of the token binding, and the other one could contain...
whoever generates that message would not be able to generate it in that case, right? So they would have to.
Well, the problem is they're generating the bytes of the message to be sent to the TLS stack, unaware of any changes that are going on in the TLS stack, and they dump them at the TLS stack, and the TLS stack writes out a couple of bytes, reaches the end of its record, then discovers that it's got a renegotiation that it completes. It completes the renegotiation, and then you're kind of off in the soup. The approach that these guys use is basically freezing the connection while there's any renegotiation going on.
I think that's the only reasonable way to do it. Yes.
We can say that. Yeah.
So yeah, what I was going to say is basically, I think Martin has it right, that the complication becomes if the application data can't be coordinated with renegotiation. I think for the spec, what we can do is say we only allow renegotiation with token binding with certain application profiles. The application profile has to allow it. And for the HTTP 1.1 case, I think we can very easily say that you have the renegotiation fits in between a client request and a server response, and then you don't have to worry about the token binding message falling on either boundary.
That's one possibility. So let's go to the next slide, and then we'll discuss what we should do. So the next slide is what we could do if we sign the original or stale AKM value, the value from the very first session on this connection. So in this case, the advantage is that an application can query the AKM value when the connection is established, cache that value, and use it for the lifetime of that connection, regardless of how many renegotiations you have, which is convenient, maybe easier to implement in some designs especially. Then fewer signatures to perform, it's not a big benefit, but in principle, it's a bit of a performance benefit. A bound token can be replayed in a renegotiated TLS session, which is, I think, a big potential disadvantage of this solution, but maybe it's not such a huge disadvantage if we really believe that TLS has fixed its prefixing issues with renegotiation. And then the server application in this case needs to track TLS connections and cannot be quite as stateless as in the former case. So in this case, the application needs to know, that here is a connection. There has to be a concept of connection, basically, and a per connection state of some sort. So these are the two options that we've talked about. There is a combined option that that has been introduced, which is, to say that the token binding protocol document will defer the discussion of the use of AKM for negotiation to a higher level document, such as HTTPS token binding document. And the HTTPS token binding document will say that renegotiation with token binding is only allowed in HTTP 1.1, and for HTTP 1.1, here's how we're going to handle it. We're basically going to use the latest EKM or the current EKM, and discuss the corner cases within that. So that's a proposal that kind of has the benefit of being, acceptable to most parties.
Yeah, so Martin Thompson, I don't think anyone's seriously considering this one anymore, are we? And are you going to argue for signing the original EKM? Okay. So the question is, where are we going to put the words?
Yeah, so my thought for putting the words is in TB Proto, we say we don't do renegotiation unless the application profile specifies that it's allowed. I think TB Proto should still have all of the words for using the most up-to-date EKM, and then the application profile just needs to describe, here is how application data interleaves with renegotiation.
Okay, I think that's, from my perspective, that's acceptable, but I would like to hear some comments from the participants as well on this one.
Jeff Hodges, this sounds good to me. Dirk Balfins, this sounds good to me too.
Well, that's great. So we'll make those changes in the documents. It's relatively small changes anyway. Yep, and I guess this is probably the last slide.
So just a quick reality check. That means that you will spin out a new document relatively soon, right? A couple of weeks or something.
Yeah, but I would even argue that we don't need to wait for that to go to last call, because it's just one of the comments. I mean,
I guess we can do that if people are comfortable there.
Jeff Hodges, I propose we call last call on the current set of docs, and the open issues we have, there's a few, are last call comments that we've already collected.
Yep.
Yeah. Or anybody feel uncomfortable with that? All right. Sounds like a plan. We'll do a working group last call right after this session.
Sounds good. And I think this is my last slide. Can you try the next one? See? Yeah, this is it. Any other comments or questions?
This is Brian. In response to the document that Nick wrote about zero round trip, there was a comment made about the EKM length being fixed that kind of by somebody else that sort of died off. But it raised a question in my mind: is that acceptable from sort of a crypto agility standpoint, that we have all these variable parameters sort of in the key parameter types? I'm having a hard time with that word, that specify different hash algorithms or different hash lengths and different key lengths and so forth. But when it all comes down to it, we're still pulling a 32-byte EKM regardless of anything else. And does there need to be some variability in that based on some other?
So the way I'm looking at this, in the past we had TLS unique, and that was used throughout everywhere. At this point, we've deprecated the TLS unique. We need to replace it with something that's standard for a variety of protocols running on top of TLS. So ideally, I would like the TLS working group to tell us, here is the new TLS unique, and it may be based on the EKM, right? And here are its parameters. Here's the length and whatever that's recommended, and we would just use that. That's the way I would do it. But Martin seems to be willing to say something too.
Well, just maybe to clarify, at least what I'm thinking of is we have 3 key parameter types right now that are roughly of equal strength and correlate pretty well to 32 bytes. But say something happens in the next year and all of a sudden we need, ECDSA 512 because that's the absolute minimum because of some, I don't know. But then we're still hashing it. We're still playing an EKM that's of shorter value than that and using a smaller.
I can see your point. Yes, I think that matching key length and hash length between algorithms is not a very trivial task.
I'm not suggesting.
And I agree with you that potentially, like an internet draft that introduces this new key type could say, and you use the EKM of this other length. In that case,
I guess
right?
it could, but you look at the way things are structured right now, and there's a very clear extension point for key types, and the EKM length is not there.
It's not there,
core
yes.
specifications.
Yes.
So I'm wondering aloud whether that should be slid over, that the length of the EKM is part of the key parameter definition. I don't know. Yeah. It's a question.
It could be done. Could be done.
So Martin Thompson, I'm not a cryptographer, but we did have the same question come up when it came to, this was related to TLS 1.3 and the size of the output for carrying over sessions, so the PSK that we had. And Hugo was very clear that it would be okay to have 32 bytes, 256 bits was sufficient. However, well, in the cases that we're talking about. So one of the key properties that we were looking for there was that there was no truncation of the hashes throughout the process, so that we had collision resistance for the property that was coming through the system, right? So if we were truncating at any point, then we would lose collision resistance for that parameter that came out. And this is pretty much the same sort of property that we're looking for here. So my intuition is that 256 is okay, but I think Andre's suggestion is probably the best. I would sort of advise maybe saying that for the signature schemes that we have defined in this document, the length is 32 bytes, and don't say anything more than that, so that you sort of have a little bit of slack if someone wants to define a 521 or the new 448 DSA curve, and they want to put in a 90 byte EKM output, then they're entitled to do that.
Right. So to the extent that I remember the document right now, nothing really prevents you from like writing a new document that will give a different EKM value.
Right. But if it seems too concrete, and I'd suggest, Brian, if you want to have a look at the document and just see if the document feels too concrete about the number 32, try to find a way to sort of soften that a little bit so that it's very clear that it's 32 for these ones, but it might be something else in future. Then that would be a fine thing.
It's also not something where we have a limit on the wire. Like there's not a size filter.
You can sign 500 bytes if you really
yes.
wanted to. It's not really going to change anything. Yep. And all of the exporters can produce any number of bits. That's actually one of the reasons why maybe you want to include text that says, and as an absolute minimum, it has to be 32 bytes, in addition to whatever other requirement that you might have.
So is somebody volunteering to actually write up the proposal? Because just to get stuff
Right.
on record, right? We should like summarize on the list. Here's the stuff that we talked about. This is the concrete proposal for handling the renegotiation case. And comment of Martin should be.
If somebody feels really passionate about this, I would appreciate a pull request. That would be great.
Could somebody volunteer to do that? Because I'd hate to be sitting after sort of the last call expires and we actually don't have a proposal for the text we seem to agree to have, right?
For this, for the EKM length issue.
Yeah. Well, actually for both, right? Do you need a pull request for renegotiation?
For negotiation, I think I can write it.
Right. So right.
For this, I don't. It was more a question because I don't know if it's sufficient as it is. I was sort of an open question. I think it is pretty limiting in the document right now. as it's written, but 32 bytes, that may be sufficient for forever. So I'm not passionate about it. I was trying to defer to greater minds, whether it was really.
If you're not passionate enough to write this pull request, then we should not be making this change, I would say. You know?
I'll take a look. Maybe just leave it.
Hi, Subodh Iyengar. I left a comment on the mailing list a while ago about token binding migrations. Since then, it's kind of fizzled out. I was wondering, what is the consensus of the room? Does anybody care about migrating their current P256 key to the X2519 key, curve 2519 key later? Or people are just going to stick around with, I do P256 and I'm always going to be doing P256, and even for token bindings as well.
So, I imagine you can bootstrap in the same way. You could rebootstrap, right?
It's really nasty. The email thread is full of caveats about actually bootstrapping. So you could do it using referred token bindings, but it's kind of nasty to do that because it's shared across the whole ETLD +1. So you need to migrate your ETLD +1 to get a new token binding.
ETLD +1 is a bad idea. What can I say?
So I think when we need different key types, we can always define them at that point. And an implementation could support both old types and new types, and over time migrate to, I think that migration would happen naturally, wouldn't it?
It wouldn't, because now you've chose once you negotiate a token binding on the server, the client has to send the HTTP messages signed with that new token binding. But now you remember it on the server as the old one, so you need a different domain to actually negotiate with. So it's actually pretty tricky. The list is full of this thing. I don't want to get into the details of that. But essentially comes down to the layering problem, right? You have the TLS layer, which is negotiating the token bindings, and then you have the HTTP layer, which is signing them. And then, if you had a way to more dynamically renegotiate token bindings on the fly, so for instance, you could think of it's really hard to do this in TLS because the extension mechanism is so one of the things I proposed was on the mailing list was actually allowing the server to send back multiple token bindings in response. Right now, the server extension can only negotiate one token binding, but if we allowed the server to negotiate multiple token bindings, respond to these are the token bindings that I want, this is the old one and the new one. And so Nick actually also had a proposal about how to use that in the client to expire and garbage collect old token bindings as well. So I was wondering if anybody was really interested in that or not really.
So my thinking on this is, if you add new types of token binding keys over time, the client, those keys don't live forever on the client. So the client will eventually get rid of the old one and then use the new one. You see what I mean? The client advertises all that the client supports. Right. The server comes back and says, now I prefer, out of your supported list, I prefer this, curve 25519. Right. Then
how do you get the original one? But you've already bound the client's session to this. You already bind the client's token to this key.
All it means is the client will generate the curve 25519 key, and will have to re-authenticate. That's all it means. Yeah.
Yeah. So that's entering your password, entering something, password, yes. Which is kind of so it makes migration very hard problem. Yes, yeah. So I'm wondering, so this might be maybe it's a future work or something, but I would like somebody to consider maybe some HTTP extension, maybe, so that you could negotiate token bindings. It's really hard to do in the TLS layer, but it's more flexible in the HTTP layer. So you could think of something like a migration pattern using HTTP to kind of say that, oh, I accept your token binding, but here's a new one, and somehow it authenticates back to the original.
Actually, I think if once in every few years I add a new token binding key type, and my users have to type in their password, I think that's not a bad experience.
Maybe for you, but maybe for you, but users entering passwords is a pretty
At the most, it's
I think
once-
we're trying to move away from passwords as a form of authentication.
even
And
if it's not passwords, right? So,
Right.
so whatever
Or
user
some-
authentication that requires user interaction, if it
Right.
happens once every few years, I think it's actually too rare. But yes,
I would argue that people will forget if it happens once in a few years, but that's another issue completely. But it's just we should have a way of migrating token bindings in itself, like where if people don't find it valuable, that's fine, and if nobody else finds it valuable, only I find it valuable, that's okay. But I'm asking whether anybody else finds it valuable as well.
So, Martin Thompson, I'm concerned about the added complexity of something that's for something of an exceptional circumstance.
I agree with that. And I would also say, we could always have an internet draft for that, and then we could gauge interest in the working group for that,
This is Dirk. Sort of agreeing with what you two guys just said. My intuition would also be that requiring users to re-authenticate every couple of years or so doesn't seem to be the end of the world. Having said that, thinking about how one would do this kind of migration is maybe something we should do at some point, but not for this version of the spec.
This is Brian. I just wanted to agree with those as well. I think the migration kind of will happen naturally, either through forcing the login every few years or getting new devices. It's just sort of a natural order of things.
Yeah.
Clearing your cookies, that it's sufficient enough that I don't think we need to bring in the extra complexity to automate it.
Nick Harper. So one case that makes this a little more complicated than just once every 3 years is if you have a fleet of servers that a user is connecting to, if the preference for which key type is preferred doesn't change across the whole fleet at the same time, a user might be going to different machines and have to do that re-authentication multiple times depending on which server they hit. But I again think this is something that we can wait until we have this new key type added, and then that new internet draft can work on more fleshing out how to solve this problem, because it's a rare problem.
Yeah, so this side of the problem is actually interesting, but I think on the on the data center, what you would do is you would deploy all the deploy the capability to use a new key type to all the servers, and then you would enable it. Basically, then you would start changing preferences on the server side. I think that's what I would do. But I agree that that's definitely a consideration for the administrator.
All right. We done? Sounds like we're done. We're getting close to being done. All right. Let's hope we don't invent new problems. All right. So what do we do next? So it sounds like we got this done soon, and then
Well, we still have Brian.
yeah. So yeah, I expect him to fill up all available minutes. And Nick
And Jeff.
and Jeff. So we'll still be here for several hours, right? So
Yeah. it's
Brian and Nick, you want to fight it out, or did you have?
Well, yeah. Hi,
You have
Jeff Hodges. There's, we do have issues in GitHub, and there's some that some of the spec co-authors have said, maybe we're not going to do this. Might be good to firm that up. Some of the others, I think, we're going to take as last call comments and actually do them. But if I was a chair, I'd walk through the issues.
Well, we can walk through the issues. It's just that what we've been very clear about, and at least I've been trying to be very clear about, is that GitHub is all good and well, right? But issues that aren't getting discussed on the mailing list don't actually exist. And GitHub is just fine for tracking stuff, right? But if people aren't bringing, if people aren't bringing stuff up on the mailing list, then, because that's where it's supposed to happen.
Okay. Hi, Jeff Hodges again. So meta discussion is that the tools folks really need to wire GitHub up with the mailing list. So it ends up, but that hasn't happened. So what we could do is post links to the mailing list, and they're on the mailing list. But
That's fine, but they also, that's not just about sort of the mechanics of having links go back and forth. It's about actually having discussion and consensus and agreement. And if there isn't even discussion about an issue, there isn't consensus to change the core document, right?
well, the point is there is some discussion over there, which unfortunately isn't gatewayed to the
Right.
list.
And that's then the reason I know that happens, right? But we've been very clear that GitHub discussions is an interesting thing, right? But if people actually want to achieve consensus to change documents, that discussion needs to happen on the mailing list.
Okay, so then I propose that the ones that are getting pushed back on the GitHub, the issues
Right.
sitting in GitHub that are getting pushed back on, if you really
If you
care
care,
about them, post it to the list with a link back to
right.
GitHub.
Post it, post it
If you
to
don't, we're going to say,
it's going to be ignored.
But
Exactly, right?
Some of them, though, are things that are among us that I just stuck in. I went through the mailing list and noted things that we said, yeah, we're going to change this, and created issues because that's a mailing list itself kind of sucks to keep track of this thing, right? So anyway, so some of them are things we're going to do. Some of them are things that we're getting pushed back on, just so you know.
Right. That you're absolutely right. There might actually be issues that reflect existing consensus, right? And we'll have to look at that. But the principle is this: once we issue the last call, everybody who has an issue on GitHub really needs to go and say, this thing I would like to talk about. That's a last call. That's a last call comment. If you don't bring that stuff back to the list, it doesn't exist.
This is Brian again. Speaking of things on the list, sometimes they don't exist either. Seems like, so I did have one issue I raised a while back about some language, and I think it was the implementation considerations being what I felt was too restrictive relative to the OAuth use case. And it just kind of just sort of sat there. Talking about it this morning in OAuth, I think I got Dirk looking at it, but I'm not actually sure how to what to do with that, because
So what to do with that is to sort of bring it up. Well, you actually take the opportunity to bring it up during the session right now, because we can have a discussion. It might actually help you. But just because somebody brings up an issue on the mailing list, and if nobody else thinks that's something they care about, that means you don't have consensus.
that's fair.
That happens, right?
There was 1+1 and then nothing.
Yeah, that hardly seems like consensus for changing something. Right, that happens, right? It might just be because people were, too focused on other things that was going on the list. That happens, right? So, bring it up now.
Okay. There's language in the implementation considerations that says in order to reveal the referred token binding, there must be explicit signaling from the party from who it's coming from. And the point on the list that I made was that there's basically not explicit signaling in that case for OAuth, and that clients are more or less the implicit signal. They're set up, not web browser clients, but OAuth client applications are set up to know the parties that they're interacting with, reveal information between the two of them. And so I was asking that the language be loosened a bit to allow for sort of predefined implicit relationships to reveal the referred token binding header. And while I know this is a privacy concern for a lot, it's people that are thinking about it in the web browser use case. And I don't want one giant token binding ID that can be tracked everywhere. But in the OAuth case, there's already correlatable information flowing between these parties in the form of an access token. We're just trying to get the language in there that accounts for what we need to do with it, which is allowing the client to reveal the referred token binding ID based on sort of pre-implied knowledge of the relationships.
Andrei Popov, Microsoft. So this makes sense to me. We discussed this earlier today in the OAuth session, and I believe Dirk agreed to make this change. If you can make a pull request, that would be wonderful to make it easier for Dirk to get to it. But I think, yeah, Dirk is in agreement to make that. This use case does exist.
So maybe I'm arguing about nothing. I was more just wondering about how to
No, you're-
track it through and make sure it's changed. And Dirk's smarter than me, so I was hoping he'd
No,
write it,
you
but
didn't-
I can
You
take a
didn't
crack
harp
at it.
about something. We solved it, right?
Done.
Yeah. But you committing to do a pull request now, right?
Yeah.
Excellent.
Nick, so I think I was one of the people who asked for that sort of explicit signal language. And basically what I mean is that there is some sort of signal like what you described of they've prearranged, but we know that they're going to talk to each other. So as long as it's not like, hey, I'm just going to send this referred token binding to everyone, that sounds good.
Okay. Thanks.
Right. I think we also need to make sure that the language isn't too restrictive. Once we get fetch for JavaScript, there isn't, when the JavaScript is deciding to send a referred token binding, there isn't necessarily an explicit signal from the place that it's being referred from, because there's no 302 in that case, at least with OAuth. So so somebody has to make a decision about whether or not you want it to be correlatable. It's not necessarily the server in the JavaScript case. It's the JavaScript that's included. Yeah. So we don't have the JavaScript layer yet, but when we get to that, somebody's going to go, oh, but there is no no signal coming from the referrer to say that I'm allowed to include this referrer in my fetch request. Maybe I can't actually send a referrer anytime because the spec has precluded it.
Vinod from Google. So I've been working on the fetch spec, and basically the idea there is that the JavaScript will execute in the origin that the request is being made from, so it can decide whether it wants to send the referred binding or not.
Yes, but if the spec says that there must be an explicit signal, where is that signal coming from?
The requesting origin is controlling whether it's going to request for the referred token binding to be added or not.
So, Martin Thompson, I think the concern that John raises here is that it's not the owner of that binding that's actually making that request.
Right.
It's the owner of the person making the request. It's the person making the request that's making this request now. So now you have potentially 3 parties involved, and one's making a decision for another, and that's potentially fraud.
I think but
I mean,
that may be true, but we have more.
And you might create some language that might cause that to be read as illegal.
Right. So potentially in the JavaScript case, you have 3 parties involved.
Which 3 parties?
Well, the JavaScript might be using cores to say, I want a token, give me a token. It might be talking to the token endpoint, saying, give me a token, but for this guy, which is the referred token binding. So the origin of the JavaScript may not be either of those HTTP calls that JavaScript is making. Maybe making a call with a referred token binding. It may want to make a call to the token endpoint with a referred token binding for the resource server, but neither of those may be actually in the origin of the JavaScript. I mean, JavaScript is weird. Don't blame me.
So sorry, this is Dirk. So the JavaScript cannot talk about token bindings of any other origins than the one that is its own origin, right? So when it causes an outgoing call to another origin, all it can say is include a referred token binding. And that implicitly means the token binding of the origin that the JavaScript, that is associated with the origin of the JavaScript.
Okay, well, we should probably be clear about that because that kills off a bunch of use cases.
Okay.
Because the resource that you may want to include the referred token binding for may not be the same as the resource of, or the origin of the JavaScript. Now, from a security point of view, that might be okay that we put that limitation on, but we should probably think, because some people are going to go, oh, that's a weird behavior. I wouldn't have anticipated that.
Right.
I expect that I could say, send a referred token binding for any place. If from an OAuth developer's point of view, being able to include any referred token binding will seem like a perfectly reasonable idea. From a security privacy point of view, maybe not so much.
Right. So what we're currently doing in Fetch is the equivalent of this header that we have in here. Right. The header, it's just a Boolean, right? That says yes, you can do that. And what the that is you can.
So the header is from the origin of.
Release to the other origin the key that you're using with me, right? That's what the header means. And the same thing where we give the same ability to JavaScript.
So.
It's just.
But is that only from the origin of the JavaScript or from any other place?
So if you want to refer a token binding from Andre to Vinod, you can't do that. You have to use your own token binding when you're referring. Your referral is only from yourself. It's when the request is made with Fetch with this Boolean flag on, it is as though a request was made to your origin as the JavaScript origin, and you were referring from that. Now, if you're trying to do the three-party case, which I agree is actually an interesting case from an OAuth perspective, you lose, because it's just not possible in the API to say, I would like you to lift the token from this origin and feed it to this origin over here. It's just not possible in the current form of the API.
Okay, so that's good information to know.
Andrei Popov, I also think it would have been insecure because that would allow a website to essentially scan the client machine for tokens, to skim the token bindings that the current machine has and to send them wherever they want. And that would be not good for correlation. I mean, that would be a security hole, I would say. So I think the limitation that Dirk is talking about is very useful from the security perspective.
Ben Kadek. So, I mean, in some sense, what you want to do is you say you have some particular origin that has its token binding, and it wants to say, I am okay with you referring this token binding, or I am okay with anyone referring this token binding to some other site. And if you say that, then you might be able to have the JavaScript from a third origin be able to use the token binding from the first origin to send to the other place.
Yes, but that appears not to be what the Fetch group is doing.
Sure. But you may not be able to get away with just a Boolean value. You can refer this token binding. You may need to be more specific.
So I think in the narrow sense of the question, we've answered that there will be a header that the JavaScript, when it's loaded, will be set, that will give an indication to the browser that it's okay to send the referred token binding for the origin of the JavaScript to the other site with the provided token binding. So there is a signal, there is an explicit signal.
Hi, Jeff Hodges. So the Fetch spec is open, and the work on it's occurring in GitHub. I'm sending a pointer to the pull request where this is all occurring to the list. So you can go look at it. If you have issues with it, you can make comments right there.
Yeah, so Martin Thompson, I'm not all that enthused by the notion that we have yet another cause header, which is basically the path that Ben was heading down, which is, sec, access control, allow, referred token binding. It might be the longest HTTP header field name ever, but I'm not all that enthusiastic about that, simply because I think people don't really realize the implications of opening that up. And as a property that belongs to ETLD +1, it's something that could be given away by any resource sitting on any number of servers, simply by producing the right header field, which to me suggests that the standard sort of adversarial models about site-wide, domain-wide properties would make that impossible to actually respect. You would receive this header field and you go, well, I'm not sure if this guy actually has authority over the origin, so you have to have another mechanism, which complexity associated with that, and so on and so forth. So I'd advise sticking with the current strategy that we have.
Yeah, so do we want to do, we have 0 RTT and
I think
reverse proxies?
reverse proxies. Who's first? Do you want to fight it out, or do you want to flip a coin, or what? Quickly, flip a coin. Right. All right. 0 RTT it is.
Okay, so I posted an internet draft on doing token binding with 0 RTT TLS 1.3 connections. Next slide.
No.
So basically the sort of problem that we have with applying the current drafts to TLS 1.3 is that we can't use the exporter from RFC 5705 because we don't have a complete handshake when we're sending application data. TLS 1.3 defines an early exporter that we can use. So basically this becomes a question of when do we use the early exporter versus when do we use the 5705 style exporter. Next slide.
No.
How many slides do you want?
The one after this. When we're sending early data, we need to use the early exporter because that's the only one available. If we have no, if the 0 RTT data was rejected, then we need to use the 5705 style exporter. Otherwise, if there's no, if the early data was rejected because of lack of keys, it's going to be able to verify it. So really this comes down to a question of if these early data is accepted, do you use the early exporter or do you switch to using the 5705 exporter? And in my draft, I'm proposing that we continue to use the early exporter. This is actually rather similar to the discussion earlier about EKMs and which one do we use with renegotiation. Essentially, what my reasoning here is that with an HTTP2 connection, you could have over 0 RTT, the client sends some early data, and right before the handshake completes, another stream on that HTTP2 connection starts to send a message that sends early, and then the handshake completes before it actually gets sent down to the TLS layer. So from an implementation perspective, it's much easier to just stick with the 0 RTT exporter. Does Martin have a question?
Yeah, Martin Thompson. No, I have a comment. I think this is a bad idea. The early exporter has different properties to the full exporter.
Yes, it does.
And I don't think you want to commit to those properties. And that's what you've done. And you're reaching a different conclusion to previously. I was going to suggest instead that you create some sort of indicator on the token binding that says that this is using 0 RTT exporters, and then you might have to do some sort of nasty stuff with setting sunsets on their use, because in the case where there are cases where you will attempt to do 0 RTT, serialize a request onto the wire, and then replay it in 1 RTT, and you're going to get a different exporter. What are you going to do in that case? So these are
sorry, could you clarify that case?
So typical behavior for these sorts of things is someone generates a request,
Yeah.
and the request sort of sits in some sort of struct somewhere with all the different header fields already ready to go, and maybe even a stream of a request body sitting there, and then the HTTP stack will stick it on the wire, and if 0RTT is available, it'll stick it into the 0RTT.
Yeah.
And if 0RTT is rejected, that same request is going to be sent over the connection. What do you do with that?
So this
Because the HTTP stack is going to do that to you.
Yeah, and this I think has to do with the 0RTT reject in TLS 1.3.
Right.
How high up the stack do you need to go to resend the data? You at least need to go up to make the decision of HTTP versus HTTP 1.1 in terms of if ALPN changes on
Right.
that. And this means that has to.
You have to go even
Drop below
higher, and
wire.
you actually have to override header fields.
Yes.
That's not something that people are going to be accustomed to, but I guess we'll have to deal with that, won't we?
Yeah, that it was a thought that had crossed my mind, and I didn't have anything else. I haven't had any better ideas on how to work around that, but certainly ideas are welcome to make it so that we don't have to jump that high up.
Yeah, do you plan to, yeah, I guess like if it rejected, the server cannot know the 0RTT exporter, so it has to, so
Yes.
those requests will fail when it gets retransmitted. So what was the other solution potentially is to just use the 0RTT exporter for the rest of life if.
Yeah, so what I'm proposing is that if the 0RTT data is accepted, then we continue using the 0RTT exporter for the rest of the connection. If it's rejected, then we end up with this issue. Okay, so next slide. So basically negotiation stays pretty much the same as what we're currently doing. When the client does the 0RTT connection, it sends the same token binding negotiation extension as before, and it uses the same key type as before. So the basically like with ALPN or SNI and TLS 1.3, you have to remember which token binding type was used as well. If the server wants to change the key type that's used, then it can reject the 0RTT data, or likewise, there are cases of rejecting 0RTT data like before. Next slide. So one of the issues that was raised on the list was around security considerations, and specifically for replay protection. I'll get into more details on security considerations, but basically this early exporter is something that is replayable. This depends on the server configuration. So this is basically an idea of like a way that the server can provide a bit of information to the client on whether the server has any replay protection. It's just an indicator extension in TLS, which looks pretty boring. Martin?
Yeah, so Martin Thompson, I don't think that we need this sort of mechanism. If we need this sort of mechanism, we would want it more generically than this. I mean, token binding is not a special snowflake in this regard. There are many other things that might benefit from having that sort of signaling, if that sort of signaling is valuable. I don't agree that it is valuable, but we can have that discussion about whether it's valuable. But your assertion that token binding needs this sort of special protection, I think is incorrect.
Yeah, so my preference with this is that if this exists as a signal for the client, if the client cares that much, there are some things that a client can do to lessen either the effect of replay. It can't, of course, prevent replay. But yeah, if the client cares that much, then maybe they should either take certain other measures or just not do this combination. Andre?
Andrei Popov. So the one security advantage that token binding brings you is that it hopefully makes the token non-replayable. If the signature in the token binding message is over the 0RTT AKM, that means that binding is replayable, because the server does not contribute to that proof of possession, basically. It's completely client-based. So it does open up a security problem. It's something we did not do, like in the case of normal TLS resumption, we have a full proof of possession, and we kind of insisted on having that because we believe that the TLS master secret on the machine is probably not as well protected as the token binding key. So where I'm going with all of this is that there are several ways that this problem can be mitigated. One of them is for the client to protect the TLS state, TLS resumption state, as well as it protects the token binding key, in which case it's moot that we don't do the new proof of possession. Another way to do it is to do some form of replay protection on the server. But I want to say that it's useful for the client to know whether the server does that or not. I think it's a useful thing because the client might decide not to do token binding with that server, for example, if it doesn't.
Yeah, so my argument there would be that if it's useful for this, that it's also useful for replaying things like requests more generically.
One case here is that if a server is doing some replay protection, they could be doing it specifically for token binding in a way that doesn't apply to 0RTT in general. Some solutions could be used for both. That I think depends on, is the signal useful for other cases as well, and use one signal versus is the signal only useful for token binding.
Kyle Neckwitz, like I agree with Mark on this point. When we're talking about replay here, you can only replay it with the exact same data that's following after the replayed token. So,
no, that's not the case here.
For the,
So yeah, so what can the sort of a replay case that is here is you have an attacker. Actually, if you want to scroll forward a few slides, I think I have this in one more slide. So if you have an on-path attacker who has the PSK, then that attacker can sniff the 0RTT traffic, decrypt whatever application data that the client sent, including that token binding message. It can then take that it can take the client hello up to the application data, use that same client hello, put in whatever application data it wants using that PSK, and send that off to the server. On this slide, I'm assuming that this is sort of resumption style where you have ECDHE and the attacker only has the PSK. Then the attacker doesn't get the response back from the server, and then the handshake, the connection never finishes the handshake. If you're not doing ECDHE, then there's more stuff that opens up there. Okay, let me see, where was I? Security protection. Can you scroll back a few slides? Yeah, right there. Okay, so one of the things that I wanted to mention with this is the way I have 0RTT with token binding proposed is that if either side wants to do sort of the way I assume token binding would be done with TLS 1.3 with the existing draft and do 0RTT, a client or a server could choose to do either of those and not do the combination of them. A client can choose to never send 0RTT data if it's doing token binding. A server can look at an incoming connection with 0RTT data and a token binding extension and decide I'm going to reject the 0RTT data, so I don't have to worry about that. So this is set up in a way that if either side is concerned about the security of this, they can say, no, let's not do it. And that leads me into the security considerations. So I think forward 2 slides. Okay, so I described the PSK sort of resumption style with ECDHE. If there is a pure PSK trying to do this, this is sort of an area where I thought things get really dodgy and would kind of prefer not to do this. With pure PSK and TLS 1.3 and token binding without 0RTT, an on-path attacker can, with the PSK, can hijack an existing connection, continue to use the token binding message in it, and can take control of that connection to do whatever it wants. With 0RTT, what this attacker now is able to do is use that token binding message and replay it on infinite number of connections, unless the server prevents the client from reusing a client hello random value. That is, like, I think the only bit of protection that we could get out of that to prevent that replay. Next slide. I talked about that one. Okay, and so mitigation. So on the server side, for basically preventing these replay attacks, the server could switch to, instead of doing session tickets, do basically a session cache with issuing new session tickets and prevent all 0RTT data replay. And then this issue goes away for that server, I believe. Or for the PSK case, since there aren't any new session tickets, basically require that the client random and PSK pair is never replayed. The server could also do a sort of replay attack on token binding signatures and basically check that that token binding signature, once has been seen, is never seen again on a new connection. I have this idea has been proposed, but I haven't looked fully into the details of this. Another mitigation on the server side, and this does not prevent all replay, it just sort of limits the window of time for it, is the ticket age in the resumption, and the server can limit that time window as much as it can, since that's one of the values that will be in the client hello, would contribute to the PSK.
Ben Kada, maybe this is obvious, but you probably want to do a combination of the time window and some of the other stuff, because then you don't have to have an ever increasing replay cache size.
Sure. If you know how small that time window is, then that for all time, I think, becomes for that time window. On the client side, Andre, I think, mentioned this already, which is that preferably the client is going to strongly protect the token binding key. If the PSK is protected just as strongly, then an attacker, basically, the attacks that were mentioned earlier is all about an attacker with the PSK. If that PSK is protected just as strongly as the token binding secret, then the attacker presumably can just steal the token binding key. A sort of careful note that I wasn't clear about earlier in some of the drafts is that this doesn't prevent replay. An attacker could steal the PSK and replay it using these attacks. It just means that they could just as easily take the token binding key. So why are they going to bother with replay attacks? So yeah, that's the summary I have of this draft. And is this something that the working group is interested in?
Yeah, so Martin Thompson, I don't think we actually closed on the use of the early exporter secret. I think we had a couple of people uncomfortable about that. Do you want to spend a few minutes on that before we proceed?
Sure.
I would like to strongly argue for not using it any more than you have to. I realize that that's going to be difficult in things like H2, where you have some uncertainty about where the transition from 0RTT to 1RTT keys actually happens in practice. You have all the scheduling problems, and there are data limits on 0RTT, and there are a bunch of other things like that. But having an explicit signal that this particular token binding is valid for only, it was derived from early keys rather than main keys, it would allow you to at least limit the number of requests that you have the token binding generated off the earlier keys.
So one of the ideas that I was considering for this, and I believe I described it in the alternatives considered section of the doc, is sort of like a ratcheting mechanism. The idea is the client can send 0RTT, a token binding message using the early exporter, and it can continue using that after the handshake completes. But once it switches over to using the normal exporter, then it can't sort of drop back. This, I think, still has issues with HTTP2 in terms of how do you implement that. If you have multiple streams writing to it and then the server reading from it, making sure that you know when that synchronization point is.
Yeah, so did you consider having simply different code points for the early ones so that you have an explicitly different token binding key? Like different signatures, different scheme for the different type for all of the 0RTT ones. So you would say that rather than doing the P256 ECDSA one, you have an early P256 ECDSA one that uses the early exporter rather than the full exporter.
Yeah.
And then you have an explicit signal in your tokens that says I'm using this one, and then the server can still maybe do the latching thing. Maybe it has to have a bit of allowance for a little bit of skew on the request, but it can say, well, it can directly identify what's going on rather than what you would do trial signature verification? Is that your proposal? Is that what your alternative entails?
Yeah, I guess it would involve doing that. Yeah, you raise a good point. So for the when you're mentioning like have an explicit, this is say P256 early, would that be a separate key that the client is using, or same key but just a different signal to say like this is
Same key, different signature scheme potentially, yeah. And then you would need in the same way that Andre said that you get a different, you've got a completely different key that you're signing over. So it's probably safe to use with all of the same, the rest of everything being the same. But that also supports Andre's decision to put the type under the signature, because now you have a further differentiator on the signature inputs.
Yeah, that sounds like it could be reasonable to have a different type in there, certainly in the token binding message signal, whether this is early exporter or not.
So both anger. Yeah. So have you ever also thought about the decision comes to like when do you latch onto the forward secure keys? So have you thought about like adding an explicit HTTP2 message which says that this is to get into the weeds, but like this is end of early token binding. It seems like that has to be done, otherwise like we can't do this with HTTP2.
Yeah, I haven't considered adding a specific HTTP2 message that if
This is Dirk. I was just going to make sort of a meta comment saying that I think this working group should take on this kind of work. As we see here, there's some interesting conversations that can still happen back and forth. But I think if we sort of adopt the document, that gives us a nice frame to have those conversations.
I was waiting for a right time to inject that question. But thanks for bringing it up. Yeah, there are a lot of comments, and people seem eager to discuss. But I want to ask the question of the working group and confirm on the list. And I'm assuming you actually want this to be adopted. Yeah. All right. Let's do a hum on that. For or against adopt as working group document, against adopt. So hum now if you support adopting this document as a working group document. Right. Hum now if you oppose that action. All right. So I think you sort of compose whatever changes you feel appropriate for the next time, and then the next spin you republish as a working group document. And if you're unsure about the naming, just ping us off offline, right? And I think Jeff.
Yeah, hi, Jeff Hodges. So there's a process question in terms of, do we continue with our current stack of 3 specs, go to last call and issue them without finishing this 0 RTT work, which I presume we kind of want to do. But should we say something? Does that imply we need to add a sentence to the protocol spec saying, don't do 0 RTT with this at this time? I mean, because we haven't addressed this issue in the current spec, right?
So my opinion on this is that assuming the token binding core docs get published before TLS 1.3, then I don't think that the issue matters at all.
Right, right, because this is a 1.3.
Yeah, this is
sorry,
exactly.
Multi-dimensional problem space confuses me. Okay,
so I mean, maybe it's more likely to say that we, you keep working on this, and maybe we finish a 1.3 version of token binding before, and maybe merge, right? Right. That's another story.
Sure. There's a separate question of whether there should be one doc, like this doc expanded to describe how to do token binding with 1.3, or if that's a separate doc and from this.
Right.
But that's that's just document management. We can.
Sure. Yeah, these questions were raised a while back as to whether we ought to say explicitly in the spec or not, and we decided no at that time. That
I mean,
that it applies to just TLS 1.2 and earlier. It doesn't currently say that, but whatever.
Right, it applies to the TLS version that exists now.
So Martin Thompson, I don't really have too much of an opinion on the timing of these things. It's going to happen as it happens, and we're kind of running into a race condition at this point, and maybe it really doesn't matter. And if we lose the race, then we might have to refer to TLS 1.3, but I don't think that's a problem in this case, because the definition of the exporters is different. You actually have to explicitly say that you're using an early exporter when you use an early exporter. So talking about early exporters, or simply not talking about early exporters as if they don't exist, is okay.
So what you're saying, anybody who implements this is going to figure it out anyway, right?
Well, as I discovered when I implemented early exporters on Saturday, you actually have to have two separate APIs. Now, Nick said this, and I didn't quite realize why, but you actually really need two different interfaces for these things. So it's like a completely new function. It has a completely new name. It has a completely new capabilities and properties that are associated with it.
Right.
And as long as we're clear on the fact that we're using exporters, I think we're okay. We might put a sentence in there saying, no, it's not early exporters, but that's the most that we would do. And I would suggest doing that if we have to update to reference TLS 1.3.
All right. Yeah. Somebody do a pull request with that. I'm just going to be a stickler for actually getting this done. So I think respin with a new name under the working group header --00, right? And again, if you're unsure about naming, we'll just ask us and we'll figure something out. And then we'll sort of keep racing against 1.3 and see who wins, right? Yep. All right. That was it?
Yeah.
Nothing else? Okay. Brian, you're up.
Next up, TLS Terminator.
Hopefully this won't take too long. I want to talk a little bit about HTTPS token binding and TLS termination. And next slide, please. So it's really, really common for HTTPS application deployments to have some kind of system up front that terminates TLS, generally a reverse proxy, and sitting in front of the application itself. For applications in these kind of deployments to actually be able to do something with token binding, some information needs to pass from that front end termination back to the application for the application to actually bind its tokens with the token binding information. In the absence, and this is going to happen, you've got like Apache in front of applications. It happens a lot with the type of applications we deploy. Nginx in front, you have Amazon Elastic Load Balancer that's being put up in front of terminating TLS and then speaking to backend applications. So people are going to want to do this, want to deploy some sort of front-end terminator in front of their applications. They're going to want to use token binding anyway. And in the absence of some kind of standard way to communicate the token binding information from the terminator to the backend application, they're going to do it anyway, but all these different implementations are going to do it in different ways. So you'll have the XTB header and the XEKM header and the X token binding header, and this will be really, really bad for interoperability between these different components. And some of us own our whole stack top to bottom. A lot of us build individual applications to different parts of the stack, and for different applications to mix and match and interoperate, it's really difficult if there's not a defined way to do it. It's definitely going to be a boon to unneeded complexity, because you'll have to have different configurations in different applications that say, well, what header are you looking for the token binding information? And who verified the actual signature over it? Do I need to do that myself, or did the TLS terminator already take care of that? And it's also an improved opportunity to get things wrong. Yeah, maybe the application's assuming that the TLS terminator verified the signature on the token binding, but it didn't really, because the different implementations made different assumptions about what's going on. So next slide, please. So proposed solution here is to work to standardize something, probably in this working group, and hopefully this isn't too controversial. It might end up being a header or two. I don't think it's too bad, but just having something written down to take care of it, I think would be useful. We've talked to some people about this, and there's some different opinions, but in general, there's sort of two main approaches to doing this. And the first is to have the TLS terminator validate the token binding message itself, do the token binding message signature validation, and then pass along the token binding header to the application, or some variation of the token binding header. I'm not sure if it's there's been talk of extracting it and hashing the individual token binding IDs. There's talk of maybe renaming the header name. I'm not sure exactly, but some variant on that where the TLS terminator takes care of the work of verifying the token binding message and passes sufficient information back to the backend. You want to comment on that or get to the next one?
Yes, Andrei Popov, I wanted to comment on that, or at least ask the question. In this case, would it be sufficient to pass just the token binding ID? Like the application only gets the token binding ID if it verifies, if it's verified by the terminator. If it's not verified or verification fails, then it doesn't get that token binding ID.
It doesn't get it at all. I think that would be sufficient, but you also need to expose the referred token binding ID.
Well, it would be like an array of verified token binding IDs, basically. That's what I was thinking.
I do think that would be sufficient. I wonder if it wouldn't be easier to just pass the whole message so it's not rewriting and re-encoding, and that the parsing logic could be the same. But in principle, yes.
I just think if the terminator has already parsed and verified the binding, the application, all the application needs is the actual ID to use it. You see what I mean? So that we don't parse it twice, once at the terminator, then at the application.
There'd still be some parsing, right? It's just a little bit skinnier, but yeah, I think yes.
So Martin Thompson, I think Andrei's design is one. The other design is one where you perform the export at the terminator and include that in a header field, which is there. And I think those are the best options. The third option that I could think of was send the master secret. That would not be a good idea. No one do that. I just had to put it out there. Do you have anything else?
No, I didn't.
Those are the only two good options. I kind of like the token binding ID one. If you think the TLS terminator is going to be doing anything, if you don't think that the TLS terminator is going to be doing anything, as I tend to believe, the just putting requiring it to put the exporter in there, exporter output in there would be perfectly fine.
Are you suggesting that we need both?
No, I think you need to choose.
Choose one. Okay.
I would lean toward putting the output from the exporter in there simply because it would shift more of the responsibility to the thing that actually cares about this, rather than forcing all of the complexity onto the guy who's really just, I'm just sitting in the middle here terminating TLS connections, right? I don't know, that's fine. It's not you. So that's my preference. I'm not sure what others think.
Okay, let me talk about that a little bit. So the other option that Martin beat me to is that the application itself could validate the token binding message signature, and it would need sufficient information provided through some headers to be passed along from the TLS terminator. That includes the EKM, so the terminator would have to do the export and encode that and send it back somehow. It also would need to include the negotiated key parameters, because that's one of the musts in the spec, that you have to verify that what was negotiated against what's in the token binding honey. So there's a little bit more information that will need to come along. I was thinking about this a little bit. It'd be really hard to terminate the connection, which is also required by the token binding spec if there's a signature mismatch. I don't know how you do that. You'd have to invent some kind of HTTP status code and pass it back up and then have the application terminate there.
Yeah, that is why I don't like that requirement.
That's
right.
Fair.
And there are many people who don't actually have access to the connection who are looking at these things, and if you're telling them that you have to terminate the connection and they don't actually have the connection, then I think we should probably look at that requirement again.
Well, but it wasn't meant to be. Well, yeah.
Right. I get your point. This is a requirement that we have in the protocol spec. That
if that requirement stays,
right,
I think it's much more difficult to do option 2 correctly than it is option 1, assuming that requirement in the base.
Right. Easy fix though.
And then going back to renegotiation a little bit, it gets even harder in this case to identify at what point in time the actual renegotiation occurred relative to the message that you're getting. So yeah, Some miscellaneous thoughts. I'm not sure what to do about version. We have this version piece in the real field. We've kind of made a gentleman's agreement. We're not actually going to use it, but it's there. And presumably it actually parse the message. You should probably pass that back. I don't know, but maybe we could get away with just passing the IDs and not worry about it. Either way, the component, the TLS terminator, needs to sanitize headers so that if we're using a new header to convey the token binding IDs raw or reconstituted, that if the terminator needs to look at that and make sure that a client's not sending them in directly, it needs to pull them out and make sure that you can't sort of work around these mechanisms. I am proposing either way that only one level of proxying be supported. So it's very specific to a use case where there's two pieces of software that are trusting each other explicitly, the TLS terminator and the backend application. And you just want to convey the token binding information between the browser client and the termination to the backend so it can do it. I don't want to get into the situation where we're dealing with token binding between these two components and these two components and these two components and trying to pass that information through. I think it adds a lot of complexity. It's not necessary. And either way, the backend application likely needs to be sort of either coded for this situation or have some kind of configuration to say, yes, I am behind the terminating TLS system or I'm not. Next slide, please.
Before
Oh,
I have a
sorry.
question.
I apologize.
Subodh Angar. Can you go back to that slide? Yeah, I was just wondering, have you considered the non-HTTP terminating case? For example, it's very common to have just pure TLS terminators, which just do TCP term, and then forward the request upstream. So in that case, like token binding, the first mechanism won't work for them, right? So how do we deal with those?
I haven't, and I don't know.
So like we have many, we don't terminate HTTP this way, but like we have TCP term with TLS termination as well. So, and it's very common for everyone to have this. So it seems like we should account for that as well in like a particular case where the first option might be discounted as a result of that.
So I sort of heard, I just want to catch this because I'm on last call patrol today. I sort of heard there might be some requirement for updating the core document spec to support some of this, or? Yeah. Right. So this needs to get documented somehow so we can actually get people.
Yeah, I will raise the item again on the list, which is if token binding is bad, can we please remove the requirement to drop the connection?
Right, and do a.
Because it's just incompatible with this and a number of different architectures.
Can you do a PR for that one?
I'm happy to do that too.
Thank you. I mean, just sort of, I just want to get everything sort of well documented now that we're closing, so we don't wind up with a bunch of issues that we don't know where they are, and whether we care about them or whether they were just entered in GitHub and we decided to ignore them, right?
Yep. So I was going to get up. Do you have any more material on this one?
I don't remember what the next slide was. I think it's.
Oh, okay.
Yeah. So if the token binding is Subodh Angar, if the token binding is bad and we want to reject it, maybe it might be useful to add a custom status code for the application to know that the request was rejected as a result of token binding failure, so that it can retry the request, not it was rejected due to some other.
Yeah, we have. I can never get 401 and 403 right in my head, but one of those, I think, is sufficient.
That would be good enough.
Now you just made my PR harder. Now you can write it.
So the question then is, and I hope the answer is yes, does the working group think this is worth pursuing? Do you want to formally ask that, or
Sure, we should.
let it marinate?
So who thinks this pursuing this work in the working group is a good idea? No. Right. Who thinks it's a bad idea? Right. And who doesn't know? Who feels doesn't care? No, they don't care enough to hum either, right? All right. It seems like we have consensus for that. So, draft and working group submission.
So like, was that consensus to work on the problem or to adopt a document? I didn't.
Oh,
No
that's it.
document yet.
There is no
No
document. Yeah.
Yeah. So we're going to work on the problem. That's great. I put that in the minutes, but that doesn't really have any teeth to it because nothing's going to really happen. as a
Right.
result.
But assuming Brian will sort of, actually produce a document,
Yeah.
and then we can talk about adopting that. But there seems to be consensus for something like that.
Tony Nadlin. If we adopt this one, it's not to slow, the other ones will not get slowed down. Is that correct?
I don't see why they should. As long as we, that's why I asked.
Clarification here.
Right, Tony. That's why I asked the last question about this question just now about that, session connection closing language, because if we agree to drop that, then there appears to be no other dependencies. So, is that everybody's understanding of this?
Yeah, I actually didn't think we were going to drop that, so I thought it was more of an argument for the first approach, but either way.
So Martin Thompson, I just wanted to get on the record that there's RC 7239, which is the forwarded for header that is intended to carry all this sort of stuff. Yeah, you wince at that. But that is exactly the trap that you're falling into here. There's a lot of people who are unhappy about that for privacy reasons, and you're kind of doing the same thing. So maybe even using that one will help smooth the path for all of the privacy concerns, because you pick up all of the privacy implications and considerations associated with that, because you're essentially exporting private material from one connection and shoving it on another one, and that's non-trivial from
Yeah, that's a lot. There's a lot more layers in that than I intended to have here, including multi-hops.
The multi-hop thing is entirely optional in that sort of thing as well. I mean, if you only, you get it for free if you use forwarded for, right? You don't have to use it though. No one's forcing you to actually put all those fields in and pay attention to them. If you've only got a one layer system, which is by far and large the most common sort of deployment scenario, you just kind of don't even include the headers or those particular fields, and when you're consuming it, you just ignore those fields. So I think that's probably okay.
Okay, I'll look again. I didn't see direct applicability of that to this problem, but
But I mean, we can always argue about the implementation details when we have a document to look at, right?
That's a good point.
So,
So,
write it up.
I will write it up. So that was, I know it kind of went against process here. You're supposed to have a draft to talk about, but I threw these together on the plane. I am happy to write this up. At this point, I'm not sure what to do except maybe write up both approaches. Although if folks want to provide any more feedback on the preferred one, maybe we can narrow it down first. I was admittedly leaning heavily towards the TLS layer doing the verification, but it sounds like there's not necessarily a wide belief that that's the right thing to do. And I'm happy to write it, but if anyone is interested in helping, let me know. And then after that, the IETF magic will happen. But yeah, if there's feedback, want to talk about which is preferred, definitely been interested in hearing more. I don't know what to do about sort of pure TCP type proxies. I'm tempted to say it's not in scope for this, but if you can explain to me how it is and how we could address it, I'd be happy to listen.
Subodh Iyengar. Yeah, I mean, it pretty much seems like you're trying to address the process of reverse proxies. You could say, like, is there only HTTP terminating proxies? And that would be it.
Okay, I can do that.
Yeah. But it seems like a sad thing where people who are terminating, like, I know how they do F5 load balancer or something, like people are just sitting in front of just pure TCP DLS terminating load balancers, like they don't get these token binding features. It seems like sad to leave them out of the goodness. That's right. Yeah. Yeah.
So,
and it's practically like this is how a major portion of the internet also gets deployed
So
where you don't control.
thank you for volunteering to write something up that we can look at how to do it with pure TCP, because I don't have the slightest clue.
Yeah, I mean, the second option's sort of like you export some of the stuff out from the TLS connection. Yeah, so the second option is kind of interesting, and like with the zero RTT, that will add some more additional flavor as well. Like the early, you won't just export the first key. You'll have to figure out what to do with the early exporter and the late exporter, and yeah, it's going to be fun.
I'd imagine exporting all that as HTTP headers, though. So
No, but you couldn't if it's pure TCP.
So, which leads me to I don't
means
know
that
how
it
to
has
do
to go into other parts of TCP, which we need other more smart or deranged people to figure that out.
So is there anything like preventing us from, writing up both approaches? Right? You do this if you're an F5 thing, and you do this if you're Nginx, right?
Probably not us.
Well, it sounds like there's
Knowledge-
three approaches.
Knowledge would be preventing me from doing the
Right.
TCP.
So I mean, somebody would have to volunteer to contribute.
So Martin Thompson, in a lot of these TCP termination cases, if you want information about the TLS connection that was on the other side of the TLS terminator, you have to have some sort of out-of-band mechanism for carrying the information, and that's usually proprietary or something else. And in that case, all you need to do in a document like this is describe the form of the information that needs to carry from the terminator to whoever's doing the consumption, and then you don't have to define a protocol or anything like that. You just have to have a list of the things that exist and have to carry across that interface and let people work it out for themselves.
Call it the turtles all the way down protocol, right?
Yeah, Pratchett was always right. Yeah.
Right.
Or you can use steganography on your TCP connection, packet timing information or something like that. Yeah.
All right.
Right. I will write. Thank you.
All right. We're at the open mic, I think. Do we have
We have what, 10 minutes?
10 minutes left? Oh yeah, Dirk had some stuff. Yeah. We're at the open mic, and Dirk has some stuff. You need a VGA dongle.
We have a VGA connector.
To nothing.
Well,
to your
to
laptop.
mini HDMI, which you don't have.
What do you have?
You have an HDMI connector?
Yeah.
Okay, then you could use this one. So you have to plug in this and this.
So Dirk has a demo for us. In the meanwhile, has anybody not signed the blue shit? All right.
Plug in the USB.
Yes.
Well, I don't know. It's not my dongle. I'll hold this for you.
Wow.
I know you.
All right.
Now you're online.
How we doing? Cool. Yes. So I wanted to give a quick plug for this library, because folks back at home were working until like 10 minutes ago to get this uploaded to GitHub. So this is an implementation of token binding that we just put out. There's a token binding library, the first link up there, that plugs into Boring SSL, or if you apply a one-line patch, also into OpenSSL. And then we have an Nginx module that uses the first library there, which transparently rewrites cookies. So all you have to do in the configuration is to basically give it sort of a secret, which it then uses to rewrite these cookies. So what do I mean by rewriting cookies? It looks something like this. If you have a server that doesn't actually know about token mining, you can put the Nginx proxy in front of it with this module in it, and you tell it which cookie to bind to the token binding. and you give it the secret. And what it will do when there's a set cookie coming through, it will tag a signature on it that depends on the token binding that it sees from the client. And then when you get a cookie from the client, then it verifies the token binding and strips the signature, so the server sees the same cookie that it set. And then if you ever get a cookie from a different server, from a different browser, then it just removes the cookie. Right. So, and just to show this, I'm going to attempt to do. All right. I have two versions of Chrome here. One of them is version 54 with the token binding turned off, and one is 56 with token binding turned on. 56 has the latest version of token binding in it. And Chrome, what it does is if you open Chrome in incognito mode, you get different token binding keys. So I'm going to pretend to be an attacker by copying a cookie out of the normal profile window and pasting it into the incognito window, thus sort of simulating an attacker who stole a cookie, and then try and send it to through that proxy and see what happens. Okay. So let's see. So here's GitHub. Going through this proxy, so you can see I'm cheating a little bit up here. I have to tell Chrome that the certificate is okay. And I'm using GitHub here because they have a simple cookie to copy. We used GitHub as the server that we're proxying, but this would probably work with other services as well. All right. Okay. I have my fingers. Okay. So now if I go, I'm not going to be able to do this standing up. Oh, seriously? That is so nice. Thank you. So if I'm at GitHub and I set the cookie, right, something like this, and then I'm logged into GitHub because that was the version of Chrome where that doesn't use token binding. Now, if I do the same thing over here, I'm in GitHub, I'm logged in. I copy the cookie, I launch an incognito window. Actually, before I do that, let me show you that this version of Chrome, if you look at the responses that go out, you can see it somewhere has the sec token binding header that it sends out, right? So now if I go through the same proxy, and do the same thing, no user session, right? And then reload this one. You're not logged. Thank you. You're not logged in because the proxy actually stripped the cookie. So yeah. So just wanted to quickly show that. And again, the libraries you can find on those URLs. Thank you.
Cool. All right. That's it. Given that we actually seem to have taken on new work, I expect to see you all in Chicago. Is it Montreal? What? Chicago is the next time. Yeah. Somebody said Montreal. Yeah. All right. You can go to Montreal. You can go to Montreal, but we will be meeting in Chicago. See you there. So, somebody have the other blue sheet? Oh, they, thank you, Wendy. All right.
So what is, so you
Figure it out. Sign another. Sign more. We're leaving right now. We didn't, that was proxies.
You have my phone.